Hello students. In today's class, we'll discuss about the first chapter of class 10 chemistry, that is chemical reactions and equations. Now to learn these chemical reactions and equations, we'll start from a topic that you have studied in class 7 and again class 9 also, that is physical and chemical changes. Now when we say physical change and chemical change, what comes to our mind? These physical changes are the changes in which no new substances are formed. So nothing new is formed, only some of the physical properties of a substance changes. Like when you talk about melting of ice, before also this is ice which is in the solid state, after the ice gets converted to liquid state. So only the physical state changes, but no new compounds are formed. So this is an example of a physical change. Similarly, when you dissolve salt or sugar into water, this is another example of physical change because no new compounds are formed here. But if a new compound is formed in a process, in a change, then that is called a chemical change. Like when you talk about cooking of food, in cooking of food, the property changes. The protein get denatured, the carbohydrate decomposed. So this type of reactions are called, this type of changes are called chemical changes. Similarly, digestion of food, respiration, burning of wax, burning of fuels, where the fuel get converted to carbon dioxide and water vapor, rusting of iron, where the pure piece of iron get converted to rust, that is iron oxide. So all these are example of chemical changes. So we can define chemical change as a change in which one or more new substances with new physical and chemical properties are formed. Now, whenever a chemical change takes place, we say that a chemical reaction has taken place. So we say a chemical reaction has taken place whenever there is a chemical change. So this chemical reaction can be defined as the interaction between the atoms and molecules to form a new substance. So a new substance is formed by interaction between the atoms or molecules. Like when you say carbon reacts with oxygen to give carbon dioxide. So this is a chemical change where carbon is burnt in air to give carbon dioxide. So if we see this burning of magnesium ribbon, this is a chemical change because in this case, magnesium reacts with oxygen to produce magnesium oxide, which has property different from magnesium and oxygen. Similarly, when you mix lead nitrate and potassium iodide, so this potassium iodide and lead nitrate, when they are mixed together, they give lead iodide and potassium nitrate. So in this case also, a chemical reaction is taking place because new substances are produced. If you see the third example, an acid reacts with a metal. So when zinc and HCl reacts, we'll get zinc chloride and hydrogen gas is released. Zinc and sulfuric acid, zinc sulfate and hydrogen gas is released. Now, if you see these cases, in all these cases, some new substances are produced. So this type of changes where new substances are produced are called chemical changes. And this chemical changes, the interaction of these atoms and the molecules are called chemical reactions. So these are some example of chemical reactions. Then whenever a chemical reaction occurs, that will be like accompanied by some physical changes also. So from this physical change, we'll get to know that the reaction has taken place or not. For example, some cases, some gases are released. If you see the reaction between zinc and sulfuric acid. So in this reaction, this hydrogen, which is a gas produced, this gas will escape out from the container. So if you take about a test tube where the reaction occurs, in this test tube, if you take some piece of zinc, and then if you add sulfuric acid to this, you'll see that from the solution, these bubbles of hydrogen gas will be released. So this type of changes where some gases are released, we can say that a chemical reaction has taken place. Similarly, when sodium carbonate reacts with hydrochloric acid, it releases carbon dioxide gas. So from release of carbon dioxide gas, which produces effervescence, like the effervescence you see when you open that cold drink bottle. When a cold drink bottle is open, you'll get that effervescence. So similar type of bubbles, effervescence are produced in this reaction also. So there are some reactions in which some precipitates are formed. Now, what are these precipitates? The precipitates are insoluble compounds. Insoluble compounds. So in a particular reaction, if an insoluble substance is produced, that insoluble substance will settle down at the bottom, and that process is called precipitation, and a compound is called precipitate. Like if you have the reaction of sulfuric acid and barium chloride, so when these two react, they gives a white precipitate of barium sulfate. So this barium sulfate will settle down in the test tube. So this type of changes will say that a chemical reaction has taken place. Similarly, in some cases, color changes. The color of the reaction mixture will change after some time. Like if you see the reaction of copper sulfate and iron, this reaction you have studied in class 8 also. When copper sulfate and iron reacts, in this reaction you will get copper and iron sulfate. So here this copper sulfate is blue in color and iron sulfate is green in color. So as a result, the solution becomes green, and the iron nail, in the iron nail, copper, which is brown color, will be deposited. So you'll get brown color copper deposited on the iron article, iron nail, which is taken. So this also is a physical change that accompanies a chemical reaction. Change in state. In some reactions, the physical state changes. Like when we talk about hydrogen and oxygen combining to give water, in this case, these two gaseous species, they react and they form water, which is a liquid. So in some chemical reactions, change in physical state also occurs. Change in temperature, this is for almost all the reactions, almost with all the reactions, but in some cases, the heat release or heat absorbed is so less that with normal our empty hands, we cannot find the difference. But in all reactions, there will be some release or absorption of heat. So change in temperature. In some reactions, heat is evolved, heat is released from the reaction mixture. So this type of reactions, the container become hot. And in some cases, the heat is absorbed from the surrounding. As a result, the container becomes cold. So this type of reactions where heat is evolved is known as an exothermic reaction, and where heat is absorbed is called an endothermic reaction. So we'll go to that later on. So based on this heat absorbed and heat release, we can have two types of reactions. One is called endothermic and one is called exothermic reaction. Endothermic reaction is the one in which heat is evolved during the reaction. So during the reaction, the reactant mixture, reactants, when they react, they releases heat. For example, these are some examples of endothermic reactions, exothermic reactions, sorry. When hydrogen combines with oxygen to form water, it releases heat. When carbon, graphite, and hydrogen reacts to form methane, it releases heat. Carbon and hydrogen and oxygen form methanol. Here heat is released. Calcium oxide and carbon dioxide give calcium carbonate. Heat is released. Hydrogen, bromine, HBr, heat is released. And the last reaction also heat is released. So this type of reactions where heat is released are called exothermic reaction. And we'll get a very common exothermic reaction that is between an acid and a base. Acid and a base. So can you tell me, student, when acid and base reacts, what other compound produce? Yes, they'll produce salt and water. So when acid and bases react, they produce salt and water. Along with this, heat is released. And we'll learn in the next chapter that if the acid and the base taken are strong acids and strong bases, the heat released is also constant. They always give whatever acid, whatever base, they'll give a fixed amount of heat. So these type of reactions where heat is released are called exothermic reactions. Then the reactions where heat is absorbed, this reaction required heat for the reaction to carry out. For the reaction to carried out, heat is required. And this type of reactions are called endothermic reactions. For example, when we decompose calcium carbonate to give calcium oxide and carbon dioxide, we have to provide heat. So if we provide heat, then calcium carbonate will decompose to give calcium oxide and carbon dioxide. Similarly, this carbon dioxide and water in presence of sunlight produces glucose. This is a reaction which is involved in photosynthesis. Ammonia, when decomposes to give nitrogen and hydrogen, here heat is required, heat is absorbed. So this type of reactions where heat is absorbed, these are called endothermic reactions. And all decomposition reactions will be endothermic. We'll learn later on a type of reaction which is called decomposition, and all decomposition reactions will be endothermic in nature. Then in the chapter name was chemical reactions and equations. So what is an equation? You have studied about equations in mathematics. If I say 2 when added to 2 gives 4, that can be written as 2 plus 2 equal to 4. So this is a mathematical equation. Similarly, in chemistry also, whenever a chemical reaction takes place, that chemical reaction can be represented by writing the symbols or the formulas. And that representation of a chemical reaction is known as chemical equation. So chemical equation is nothing but the representation of a chemical change or chemical reaction. Now we can write the chemical reaction as word equation where the name of the reactant and the products are written. Like this. When hydrogen reacts with oxygen gives water, can be represented like this. Hydrogen reacts with oxygen to produce water. So this is known as word equation. If I write carbon reacts with oxygen to produce carbon dioxide, so this is also an example of a word equation. Then symbolic equation, where the symbols of the elements or formulas of the compounds are written. Like the same equation, hydrogen and oxygen, if you write like this, it becomes a symbolic equation where this symbol of the elements and the formula of the compounds are written. Like the earlier equation that I've written, carbon plus oxygen gives carbon dioxide. This becomes a symbolic equation. Now, how to write the chemical reaction? Although I've written the reaction, but these things you people should know. The symbols, formulas of the reactants are written on the left-hand side, and that of the products are written on the right-hand side. So left-hand side, we'll write the reactant, right-hand side, we'll write the product. And when we have more than one reactant or more than one product, they are separated by a plus sign between them. An arrow like this or like this is placed between the reactant and the product. So this type of arrow, which is in one direction, which is one directional arrow, this is used for a reaction which is irreversible. Irreversible, that means the reaction goes only in one direction. And when the reaction goes in both the direction, it is called a reversible reaction. And for reversible reaction, this type of double directional arrows are used. Sometimes the physical state of the reactants and products are also mentioned to make the reaction more informative, to give more information about the reactant and a product, about the reaction. Sometimes the physical states are also written. So in physical state, when you write S in bracket of a reaction, this means solid. Like if you say Na within bracket S, that means the sodium is in solid state. When you write hydrogen and G in bracket, this means the hydrogen is in the gaseous state. When you write L, that is liquid. Like when you write H2O, water, L means water is in liquid state. Now when you write NaCl within bracket AQ, this means NaCl aqueous solution, NaCl dissolved in water. Fine. So S is written for solid, G is written for gas, L is written for liquid, and AQ is written for aqueous solution. Now, can you tell me what is the difference between sodium chloride solid and sodium chloride aqueous? If I write NaCl solid, NaCl aqueous, and NaCl liquid, what is the difference? So NaCl solid means solid sodium chloride, the salt that we have. NaCl liquid means the sodium chloride solid is heated to a high temperature to convert it to into molten state. And NaCl aqueous means sodium chloride dissolved in water. So sometimes the reaction conditions, like the temperature at which the reaction occurs, the pressure which is required for the reaction, the catalyst which is required for the reactions, are also mentioned to make the reaction more informative. Now this temperature, pressure are the word familiar to you, but you people don't know what is catalyst. So these catalysts are the substances that alters the speed of a reaction. Generally, the catalyst is taken as a positive term. We say catalysts are the substances that increases the rate of a chemical reaction. It takes part in the reaction, but after the reaction, you will get the catalyst in the same amount in the same form. That means during the reaction, catalyst will not undergo any change. So no change in physical state, no change in chemical state, no change in amount of the catalyst takes place during the reaction. Like sometimes if you talk of the reaction between hydrogen and nitrogen to produce ammonia, in this reaction, iron is taken as a catalyst. and this reaction occurs at 200 atmosphere pressure and around 700 Kelvin temperature. Similarly, if we talk about the reaction between carbon monoxide and hydrogen to produce methanol, this reaction occurs at a temperature of 340 atmosphere. So these conditions are to be set in the industries to prepare this particular compounds. Fine. For the synthesis of glucose, sunlight and chlorophyll are the conditions required. So sometimes to make the reaction more informative, to give more information about the reactions, we write these conditions which is necessary for a reaction to occur. Now let us go to skeletal and balance chemical equation. So first we'll talk about skeletal or unbalanced chemical equation. Now when you say unbalanced chemical equation, the reaction is like this, is a skeletal equation where the atoms of different elements are not identical on both the sides. See here, left hand side we have 2 hydrogen atoms, we have 2 oxygen atoms, but in the right hand side we have 2 hydrogen and 1 oxygen. So atom of different elements are not identical on both the sides. It's called a skeletal chemical equation or unbalanced chemical equation. And these unbalanced chemical equations are balanced to satisfy the law of conservation of mass. We know that in a chemical reaction, atoms get rearranged only. Atoms are neither produced nor destroyed in a chemical reaction. Fine, atoms are neither produced nor destroyed in a chemical reaction. That means the mass is neither created nor destroyed in a chemical reaction. So number of atoms before the reaction or number of moles of atom after the reaction should be identical. So in this case, to balance the reaction, you have placed the 2 here and 2 here. Now if you see, left hand side you have 4 hydrogen, 2 oxygen. Right hand side also you have 4 hydrogen and 2 oxygen. So atoms of different elements are identical in both the sides. This type of chemical reactions are called a balanced chemical equation. Now how to balance the chemical equation, that we'll discuss in our next class. So thank you students. In our next class, we'll discuss about balancing a chemical equation. So thank you. Stay at home and stay safe.